Somewhere out there, right now, two entire planets are dying. And for the first time in the history of astronomy, scientists are watching it happen in real time. Not a slow, gentle fade over billions of years, the way most planets eventually meet their end. This is violent, active, and ongoing. Two worlds actively shedding their own outer layers into space, one atom at a time. Close enough for the James Webb Space Telescope to actually capture the process as it unfolds. Researchers studying this have used the word cataclysmic to describe it. And after seeing what these two planets are actually going through, it's hard to argue with them. Stick around, because what's happening to these two worlds is giving scientists something they've wanted for decades, an actual look inside a planet's interior. And if you want to catch more discoveries like this the moment they break, go ahead and hit follow before we get into it. Let's start with the first of these two dying worlds, a planet called K2-22b. It's roughly the size of Neptune, but don't let that comparison fool you into picturing anything resembling the cold, icy giant sitting at the edge of our own solar system. K2-22b orbits its star at an almost unimaginably close distance, completing a full trip around it in just 9 hours. For comparison, Mercury, the closest planet to our own sun, takes nearly 3 months to complete a single orbit. Being that close to a star comes with a price, and for K2-22b, that price is heat beyond almost anything else known to exist on a rocky world. Surface temperatures on this planet climb past 3,300 degrees Fahrenheit, hot enough not just to melt solid rock, but to actually vaporize it, turning the planet's own surface directly into gas. That process alone would be remarkable enough on its own, but what makes K2-22b genuinely unique is what happens to all that vaporized rock afterward. As the planet's surface material boils away into space, gravitational and thermal forces sculpt it into an extended comet-like tail trailing behind the planet as it races around its star. Astronomers had suspected planets like this might exist for years, based on strange, irregular patterns in how they dim their host star's light as they pass in front of it. But actually confirming it and studying the composition of that tail in detail required an instrument sensitive enough to pick apart the faint chemical signature of vaporized rock streaming off a planet many light years away. That's exactly the kind of observation the James Webb Space Telescope was built to make. When researchers led by Penn State astronomer Jason Wright and graduate student Nick Tusay actually turned Webb toward K2-22b, what they found immediately puzzled them. Mixed into that trailing tail of vaporized material were gases like carbon dioxide and nitric oxide, chemical signatures normally associated with icy, volatile-rich bodies, rather than the solid, rocky mantle of a terrestrial planet. These are the kinds of gases you'd expect to have boiled away and vanished from a rocky planet's surface ages ago, not something you'd still find streaming off it today. Tusay later described his own reaction to seeing that data using a phrase that perfectly captures the moment, calling it a genuine who ordered that kind of surprise. Researchers now suspect K2-22b might not have originally formed anywhere near its current scorching orbit. Instead, the leading theory suggests the planet may have formed much farther out from its star, in a colder region where those volatile gases could have remained locked inside it before gravitational interactions gradually dragged it inward to its current brutally close orbit. That kind of planetary migration isn't unheard of, and it becomes even more plausible in this particular system, since the star K2-22b orbits actually shares its cosmic neighborhood with a companion star, whose gravity could plausibly have helped nudge the planet's orbit inward over time. If that theory holds up, K2-22b's slowly evaporating tail isn't just evidence of its current destruction. It's a fossil record of the planet's entire violent journey, chemically preserving hints of an origin far different from where it ended up. The second dying world in this story goes by the designation BD+054868Ab, and it holds a genuinely unsettling distinction. It's the closest known evaporating exoplanet to Earth ever discovered. This one wasn't found by Webb directly, but by NASA's Transiting Exoplanet Survey Satellite, known as TESS, which specializes in watching for the telltale dimming that happens when a planet passes in front of its star. What TESS revealed about BD+054868Ab was even stranger than K2-22b's single trailing tail. This planet has two distinct tails streaming off it simultaneously, a leading tail made up of larger, sand-sized particles racing out ahead of the planet, and a separate trailing tail made of much finer, soot-sized grains dragging behind it. Together, these two tails stretch across roughly 5.6 million miles of space, occupying nearly half of the planet's entire orbital path around its star. The scale of destruction happening to this planet is genuinely difficult to comprehend. Researchers estimate BD+054868Ab is currently losing roughly a moon's worth of material every single million years. an almost unimaginable rate of mass loss for any planetary body. At that pace, astronomers calculate the planet has somewhere between 1 and 2 million years left before it ceases to exist entirely, completely consumed by its own ongoing disintegration. In the grand scale of planetary lifespans, where healthy worlds typically persist for billions of years, 1 to 2 million years is barely a passing moment, a blink of an eye by comparison. MIT postdoctoral researcher Mark Hahn, who led the discovery of BD+054868Ab, described the significance of catching this exact moment in the planet's destruction in fairly stark terms, noting that the rate of evaporation is utterly cataclysmic, and that researchers consider themselves remarkably lucky to be witnessing what amounts to the final hours of a dying planet. That framing is worth sitting with for a moment. Given how vast the timescales of planetary science normally are, actually catching a planet in the final 1 to 2 million years of its multi-billion year existence is an extraordinarily narrow window to stumble into. And yet, that's exactly the moment astronomers happen to find this world in. What ties both of these discoveries together, beyond the sheer drama of watching two worlds actively disintegrate, is what they're teaching scientists about something that's normally completely invisible, the actual interior composition of a rocky planet. Under ordinary circumstances, there's no way to directly sample what a distant exoplanet is actually made of on the inside. Even studying the interior of our own planet remains an enormous scientific challenge, given that humanity has never managed to drill more than a few miles beneath Earth's surface, a tiny fraction of the distance to our planet's core. But as these two worlds boil away into space, they're essentially performing that sampling process for scientists automatically, releasing their internal material directly into a form telescopes can actually study and analyze. Wright, one of the researchers behind the K2-22b findings, described this as a remarkable and fortuitous opportunity to actually understand terrestrial planet interiors, something that would otherwise remain almost entirely theoretical. Tousi put it even more directly, explaining that these two dying planets are essentially spilling their own guts into space, and that Webb finally gives astronomers the tools needed to study that material and figure out what planets orbiting other stars are genuinely made of, rather than relying purely on models and indirect inference. Both sets of findings, the detailed Webb observations of K2-22b and the TESS-based discovery of BD+054868Ab, were released as research papers still undergoing the peer review process at the time they were announced, meaning the scientific community continues to scrutinize and refine exactly what these results mean. But even at this early stage, the implications are already reshaping how astronomers think about the fate of certain kinds of planets, particularly those unlucky enough to end up locked into extremely tight, scorching orbits around their host stars. There's something genuinely striking about the timing involved in all of this. Both of these disintegrating worlds are caught in an extraordinarily brief phase of their own destruction, a violent active process that, on the scale of a planet's entire multi-billion-year existence, will be over almost as soon as it began. Every observation scientists managed to squeeze out of these two. Systems now represents data that will simply cease to exist once these planets are fully consumed, information about planetary interiors that would otherwise remain locked away forever, sealed inside worlds humanity has no other way of directly sampling. It's also a genuinely humbling reminder of just how violent the universe can be toward the planets orbiting too close to their stars. Both K2-22b and BD+054868Ab serve as stark, real-time examples of exactly what can happen to a world that ends up, whether through its original formation or through gradual gravitational migration, trapped in an orbit its star was never going to let it survive. Watching that process unfold isn't just a dramatic spectacle. It's giving scientists an unprecedented real-world data set on planetary composition, planetary migration, and the surprisingly violent ways a planet's story can come to an end, all captured by a telescope specifically built to catch details like this from many light years away. So, somewhere out there right now, K2-22b continues tracing its 9-hour orbit, trailing a comet-like plume of its own vaporized rock behind it, while BD+054868Ab counts down what may be its final 1 to 2 million years, spilling sand and soot into space along two separate streaming tails. Neither planet has any chance of surviving what's happening to it. But in dying, both are giving astronomers something genuinely priceless, a direct, real-time look inside the actual composition of a rocky world, delivered not through theory or simulation, but through the simple, brutal physics of a planet being slowly torn apart by the very star it orbits. If a story like this, watching two entire planets die in real time and turning that destruction into genuine scientific insight, is the kind of thing that genuinely fascinates you, go ahead and subscribe. Drop a comment letting me know which of these two dying worlds you found more unsettling, and stick around, because there's a real chance James Webb catches another one of these rare, fleeting moments before too long.